That's what I get for trying to take a shortcut and cancelling too much. If I just did it out long, I would have gotten the right answer.
1 point something? 1.3, right?
Yeah. Right, A4. There's a force down the middle here of 8.6 G. Here there's a 20.3 G, and here there's a 30.2 G. This distance here is 1.2 meters. This distance here is 0.5 meters, which means this is 0.7 meters. This here is also 0.5 meters, which means, is that it?
It's in the middle.
Oh, sorry, that's not 0.5, that's 0.3.
And the other one is
0.35. So that's a 0.3, and this one here is a 0.35. This is still, of course, 1.2. It's in the middle, and this one here will be. So that's not 0.7 then. That's 0.9, isn't it? Yeah. And this here will be 0.85 meters. And then there's two support beams, one here and one here. And this distance here is 0.5 of a meter, and this distance here is 0.5 of a meter.
Should be always the same, the beams?
No, not always. Right, so what type of problem is this now? No, moments, yeah, turning force. So where do we want to take our turning point?
B. Or A.
I'll take it here, okay? So firstly, our up forces.
They're finding A first.
Oh, it doesn't matter, I don't care. They want T and S, so I'll just T plus S. I suppose, yeah, it doesn't matter, don't care. T plus S equals 20.3 plus 8.6 plus 30.2 G. Now let's make the turning force. Okay, so the first one here, if we take this as our turning point, clockwise or anti-clockwise? This one. No? No?
It does not have any.
Yes, because
They are taking one of that.
yes, it's passing through it. So this first one here, clockwise or anti-clockwise?
Clockwise.
Yeah, and the distance to the turning point?
0.2.
0.2 times 20.g. The next one is plus, what's the distance? It will be 0.7 times 8.6g. The next one is 30 from here to here.
1.6.
Are you sure? Oh yeah, 0.9 plus 0.85 is 1.75 plus 1.95. I got KJ.
But that 8.6 is at the half.
Yeah.
So, and the two T and S are placed for 0.5 from
Yeah.
So what's left in between is 1.4.
Oh, let's just write the distances out. Right, the first one, can you, from here to here, that's 0.5 and 0.3, so that first distance has to be 0.2. Are we happy with that?
Yes.
Fine. And then from here to here is 0.9 plus...
This is 0.5, but yet the 0.3 is in front of it.
I know, I drew it the wrong way around. Oh, okay, yeah, so that's bad of me. I should have had it over here, right?
Yes.
Well, okay. Thank you. Actually, that doesn't matter. I'll move it over here, get rid of that. So if that's 0.3 and here to here is 0.5, then the distance is still 0.2. Okay. Right, now from, where am I? Here
So
to here,
0.7. Half of it is 1.2 to 1.2 minus.
you know, I think I need to redraw it because I drew it so badly. But I'll keep the forces here. You know what, I'll draw it up the top. Okay, can we all have a look please?
Yes.
Yeah. So I'll mark, here's the end here and here's the end here. So the first one I'll put in the middle is the 8.6. So how long from here to here? At 1.2. So we're okay with that, yeah? Then what's the first thing? It's in a distance of 0.3, isn't it? So I'll put that in red. This distance here, 0.3. And then it's 0.3 until the first support, so that's 0.2. And then it's from here down, because that's 0.5, that has to be 0.7. Yeah, and then this one here, it comes in, the child comes in a distance of the same, no, 0.35. And this distance here would have to be 0.15. And this, no, yeah, and this distance here, 0.7. Okay, so now my distances are correct. Right, so the first force here, clockwise or anti-clockwise? Now this is, let me get rid of that, that's ugly. What am I taking as my turning point? I forget. Here. So this first force going down, anti-clockwise. So we'll make that we'll put that on the right. So anti-clockwise, 20.3 G, and the distance we can see is 0.2. Right. The next. So that's done. That's okay. This one here is clockwise. And the distance is 0.7, and it's 8.6 G times 0.7. Yeah? Now, what about this one here? Clockwise or anti-clockwise? Clockwise, this one. Clockwise, so that goes on the left. And what's the distance? It's going to be this one, from here to here, plus from here to here. Yeah? So that's, what's that? 1.4. Right?
This is not starting from there, starting from the...
Oh my goodness, hang on. My picture's still so bad. Let's draw it again.
Big picture.
Big, clear picture. Right. So firstly, there's the child here. And this is 20.3 G. Then there's an up force here. This is R. Yes? No? No. Right, this here, 8.6 G. This here, S. And this here, 30.2 G. Okay. This distance?
By the way, that's kg.
No, this is the force. This is fine. This distance here? 0.3. This distance? 0.2. This distance? This one? This one? And this one? Okay, now it should be crystal clear. We're taking the turning point here. So this one is anti. This one here, clockwise, clockwise, anti. So let's do the clockwise ones first on the left of the equation. So the first one is here. That is 0.7 times 8.6 G. Yeah? The next one is plus 0.55. This plus this plus this. Right, to here, times S. Now the anti-clockwise, this one here is 0.2 times 20.3 G, and then this one here is 1.4. Oh, sorry, I wrote S, didn't I? I should have written 30.2. Okay, now we're happy. I screwed this up because I'm so tired. Right, this gives us the S, doesn't it? Because there's only one unknown in it. So 0.7 times 8.6 times 9.81 plus 1.55 times 30.2 times 9.81 minus 0.2 times 20.3 times 9.81 divided by 1.4, and I get for my S the correct answer as that. 342 newtons. Now when I take this answer and put it back in this equation I had at the start, I get my T. So my T will be 238 newtons. Okay, so I really had trouble because number one, I'm overworked and tired. Number two, it's Friday. Number three, it's Friday afternoon. And number four, I don't have coffee with me, as you can clearly see. So this is what it should be. And now that you draw a nice picture, it seems much easier because it is. So that is right now. Okay, let's have a look. So do I want you to try? Yeah, I'd like you to try the next tree, please.